size of this room, and it came with its own dedicated operator here. And then someone in the audience may be old enough to remember a device like this that had this tape recording device. I'm not sure you're old enough, but I am. So, and these days, of course, you get small computers like this that are much more powerful than either of the two. Same is true for data storage. The first magnetic hard drive, it was a really big box. It was like from here to there and like this tall. And it stored a whole 5 megabytes, you know. So it's probably not enough for an MP3 song, yeah. But, and we know how this went. I mean, things became smaller and smaller, and now you have music players and all kind of things that use very small hard drives. Same is true for phones, you know. The first one was the brick, and these days you have phones that are much more computers. They can do everything else besides making a phone call. And, you know, there are lots of further developments like this. But so the question is, does this very dramatic development in electronics really go on forever and ever? Or is there some limitation to all this progress? And one real problem is actually heat generated in these devices. And so what I'm plotting here is the power density in a central processing unit versus the year where it's commercialized, essentially. And this is quite astounding. What you see is that the heat increases further and further. And what happens is, as you make things smaller, you have more and more leakage currents going where you don't want them, and they produce power dissipation, which is not very useful. Now, if you look at these numbers, it's really quite staggering. Like about 10 years ago, the power density in your typical logic chip in your computer was as high as a hot plate that you use in your lab, you know, for preparing samples. And these days, it's approaching numbers that are close to what you get in a nuclear reactor. So clearly, this has to stop at some point, you know, because once the materials get so hot that they melt, obviously it doesn't work anymore. Where exactly that threshold is, who knows, you know. Maybe when you reach a number like comparable to a rocket nozzle, or certainly once you reach numbers that are close to the sun's surface, let's say, at that point you clearly burn your lap when your laptop is on your lap. But in fact, actually, if you look at this, these numbers stopped like about 5 years ago, but in the last 5 years, if you look at the trend, things actually leveled off. So power dissipation is really one of the main limits that we have to encounter. One of the positive side effects is that computers